Good morning. Good morning, everybody. My name is Jose Castaño Sanchez, and I pleasure to present the result of our research. The title is the environmental and economic impact of the supply chain options for Angus and Criollo cattle production in the Southwest region. And we will really quick in this. The background is the beef production Southwest due to Sherry covered all this before. In the southwestern United States, the beef is experienced to warmer and drier climate in the future. Most calves are rising in Southwest and they finish in feedlots. So we studied alternative beef supply chains. One is test different breed options, in this case using the Raramuri Criollo cattle and the crossbreed with traditional British breed. And second, we tested the grass finishes options and rain-fed forage in desert rangelands in the Southwest or in temperate grassland in Central Plains. So Matt talked a lot about the Raramuri Criollo before, so I will skip this slide. Basically, this way our research. We analyzed the different alternative finishes options. Basically, the idea is we have the cow-calf operation that is conducted in New Mexico in the Southwest. And after that, the third option that we analyze is backgrounding and grain finish on a feedlot in the Texas Panhandle. The calves move from here to the Texas, are transported from New Mexico to Texas. The option 2 is grass finishes in the Central Plains. We selected in this case South Dakota as our case study, and calves are transported from New Mexico to South Dakota. There is about 900 miles. And the third option is grass finishes in New Mexico. Yes, after the cow-calf operation, the calves remain in New Mexico for the finish in the desert conditions. And you can see here the different time required to finish the different calves. In the grain finish is about 18 months, 26 and close to 30 in grass finish in New Mexico. So we define it for our simulation. We try to represent ranches characteristics of these regions. So we define it for the cow-calf operation. We define it with a ranch with about 550 cows, and this increase in the cross and in the cross with Criollo. We remain the same due to use the same cows in the cross and in pure Criollo. Due to the idea in all these different options is to keep the same stocking rate, and due to the Criollo are lighter than the traditional Angus cow, we need to adjust the number to keep the same stocking rate. And the same, we made the same approach for the other options, especially during the finish stage. We have the first is the finish in New Mexico, the second one is the finish in North Plains, and the last one is the finish in the backgrounding. And you can see here we have 400 steers, stockers, and we're increasing on about 100 in the Texas feedlot operation. So we use the IFSM model. Is a process level simulation tool used to assess the performance of the environmental impacts and economics of cattle and production systems. Each process is represented in the model. The model runs on a daily time step, and also some process also run on an hourly time step. And all this process that is common in a ranch or a farm are represented: the crop, harvest, the preservation, the animal, and also the different nutrients and different component cycles with the different inputs. You can the position, nutrients, and required feed, and the different outputs from the operation, the exported animals and the exported manure. So to address the environmental impact of these operations, we conducted a life cycle assessment, and in this case, we conducted one type of this life cycle assessment that is from cradle to the farm gate. That includes from when the cows are born to when the animal depart from the ranch or feedlot. And the basic components that are part of an operation is the feed production, the animal production, and the manure handling. And the main products are, in this case, are the animal zone and the exported manure. This process produces direct sinks and source of greenhouse gas emissions. Part are fixed, and these ones are emitted: CO2, nitrogen, methane, and others. And also, these are the direct sinks and source, and also we also consider that indirect source of greenhouse gas emissions. Also, we consider the resource input: oil, electricity, fertilizer, pesticides, plastic machinery, and farm cafe is necessary, and also all the purchased feed. That is quite a big component in our simulations. And we also consider all the resources, all the pre-change source of this greenhouse gas emission, that also this will be input in the system and will be considered in the final numbers. So for this research, we focus in these 4 gate footprints or environmental intensities: the greenhouse gas emissions or carbon, the reactive nitrogen loss, the fossil energy use required for these operations, and finally, the non-precipitation water use. All these at the end will be expressed as footprints are allocated by mass and are given on a per unit or carcass weight. All the footprints that I will present the result next will be expressed in this footprint per kilogram or carcass weight or meat and bone. The first result that we have is the meat production of these different options. In this case, we standardize it across the ocean to be made comparable. And we present here this. I will be use this pattern of figures in the next slides. We have, in this case, we have the Criollo results. We have the Criollo grass finish in Southwest, grass finish in North Plains, and finally grain finish in Texas. And as expected, the higher meat production is with using grain finish, and in the middle is in the North Plains, and the lower meat production is grass finish in the Southwest. And this pattern repeats in the other 2 options of breed that we use, the Angus and the Criollo crossed with Angus. The first thing that we analyzed was how the feed consumption per kilogram of carcass weight produced. And you can see here the highest feed consumption is by the grass finish in Southwest, followed by the grass finish in North Plains, and the less in kilograms of dry matter is in grass finish in Texas. This is what expected. The truth is here the use of more concentrated feed is expected to use a less kilograms of dry matter per kilogram produced. But the main change with here is in these two systems, the higher component is the forage grazed, and in this case also we have a higher component of forage grazed, mainly related to the cow-calf operation. Due to this these results also include the cow-calf operation, but also these are the components of the grain bowl and the high forage bowl for the grain operation. This is for Criollo, and again, this pattern almost repeats for the Criollo crossed with Angus and also the pure Angus. Next, the result of the greenhouse gas emission resumed as a carbon equivalent component. And you can see here the main component of the greenhouse gas emission is a result of the animal emission. Animal emission is more related to the methane emission by the animals, and is quite constant in the three systems, but this component is much higher in this grass operation than in the grain finish, and this is related to the type of feed that is more forage, the forage diet that produce more methane than the grain finish diets. And again, you can see the pattern is more or less the same, and we have the higher greenhouse gas emission with grass finish in Southwest with Angus, and the lowest is with the cross with Criollo and Angus grain finish in Texas. The next is the reactive nitrogen losses, and the main component here is the ammonia emission as a result of the SS and or urine. In this case, you can see again is the highest value, and in this case we have the highest in grain finish in Texas, followed by grass finish in North Plains, and the less emit reactive nitrogen losses in grass finish Southwest. The main difference between these two grass finish is the type of feed that is consumed. That the grass in Southwest, the feed have lower protein, and as a result, it lost less ammonia in the SS and the urine. And we have, in this case, we have the highest reactive nitrogen loss we found with Angus grass finish in Texas, and the lowest grass finish in the Southwest with the Crossbreed. Next, we presented the fossil energy use, and in this case, the main component is the production that the main use of energy use is in the production of the resource inputs that include all fuel combustion, all these things, and also the feed consumed by the animals. And again, the higher fossil energy use is by the grain finish in Texas, followed by the grass finish in Southwest, and after that in North Plains. Again, this pattern repeats with the other breed options, and the higher emission is with Angus in grass finish, and the lowest is almost very similar in grass finish in North Plains or Southwest. Finally, we have the non-precipitation water used by the different options, and in this case, the higher use is by the grain finish in Texas, and the main component is the purchased feed for the animals. And the same happened in grass finish that is very much lower. It's almost 4 to 5 times lower than the water consumed in the grass finish in Texas. And again, we have the highest consumption of precipitation or non-precipitation water, sorry, is in Angus in grass finish, and the lowest is grass finish in the southwest. But this is will be quite confusing to present all these results. And finally, the production cost is the main component. The higher production cost is in the grain finish in Texas. The main component again is the purchased feed. In this case, the juice, as expected, is the highest component in grain finish operation. And in the grass finish, the higher component is the labor used for these operations. And the same repeat in the other feed, the other breed options, and we can see the higher production cost per kilogram of is Angus in grain finish, and the lower is really close to is grass finish in North Plains, really close to in the southwest for the crossbreed. Finally, we try to present in a uniform basis. We present here the best option, as you can see in all our previous slides, are the cross of Criollo and Angus, and we present here the environmental intensity and production combined. And you can see that in orange there is the grain finish in Texas, blue is grass finish in the Central Plains, and green is grass finish in New Mexico. Basically, you can see here for 4 of the 5 components that we are analyzing, the fossil energy use, non-precipitation water use, reactive nitrogen, and production cost, the grain finish is what have the higher values of this environmental intensity and production cost. But we can see here the greenhouse gas emission with this option have lower than the other options, and you can see here the grass finish has really similar values of the greenhouse gas emissions. The other thing is the mark here is the grass finish in Central Plains have also intermediate values of reactive nitrogen loss. So the take-home message that we have is the environmental footprints, and we have the crossbreed combining the desert adapted grazing behavior of Criollo cows and calves with heavier final carcass from Angus genetics. And this is the reason why we have, if we analyze in most of the footprints and production costs, we have the crossbreed have lower environmental footprints. The Criollo is in the middle, and the higher is the Angus. Next, if we consider the combination of breed and finish option, the crossbreed cattle with grass finish in the southwest or in the Central Plains outperforming on most environmental variables and production costs, most due to reduced external input requirements, primarily feed. And finally, the downside was greater carbon emissions compared to grain finish due to greater methane emission from higher forage diet and lighter weight at the end. Thank you very much for our presentation.